So I'm here at the Santa Barbara Museum of Art. Dos Pueblos director just gave me a call and said I'd like you to come down and take a look at our exhibit. I guess they've been doing some machining on their Haas and were asked to come into the museum to show it off. And I guess they've been here for a couple months. So I'll go in and I'm going to talk to Amir. This is Santa Barbara Museum of Art, downtown Santa Barbara, California, one of the premier museums in the Central Coast. And it's a beautiful day. Let's go inside and talk to Amir.
Welcome to the Carousel of Physics. This is a project that we developed over the course of one school year. It has over 50,000 parts. It's got 40 microcontrollers. And the idea behind this was, could we demonstrate that it was possible to create museum quality exhibits with high school students for the senior capstone class in the Dos Pueblos Engineering Academy. And so each student had their own project. This is called a sector right here. A sector is made by 4 students. Each student had their own project, so their name is on it. So this is like Zach, this is Juan, this is Ian, this is Liam here. Each of those 4 students worked together to create this sector. And the whole idea was we wanted to demonstrate concepts in physics in a way that would teach people and would also be artistic. And as a result of the success of this project, we are here at the Santa Barbara Museum of Art. We were invited to exhibit this. This is the last day of our exhibition. It's been here for 2 months. And I'm going to just kind of talk through a couple of the projects right now. So this sector right here is called magnetism.
In-house, done at Dos Pueblos.
In-house, so yeah, so there's over 50,000 parts on here, and we basically fabricated everything from scratch. The things we don't make are things like we didn't make the glassware, but everything else that you see is either laser cut, or it's made on the Haas CNCs, or it's made on our manual machines, and it's all done in-house, all over the course of this year. Definitely tens of thousands of parts that we manufactured ourselves. This first project is demonstrating that you can stir something with magnetism. So this is called a magnetic stir. And on top of that, there's this ping pong ball, which is submerged beneath this vortex right here.
How long has this exhibit been here at the museum?
It's been here for 2 months.
So 2 months.
Yes.
Constant flow.
Constant flow of people. We've had thousands of visitors. We've had people from all over the country, because Santa Barbara is a tourist town, come through here. And as a result, we've had actually folks from other museums throughout the country come and visit this exhibit because of word of mouth to find out more about what we're doing here. And so in this project, one of the concepts of the project is the marble comes through the project and stops at each project and narrates it. So this project right here, this is an example of basically, this is magnetic induction. There's a little coil right there, and that coil is generating a magnetic field, and it's able to actually push the ball. And so it's pushing the ball. So it's kind of like making people think, oh, is this perpetual motion? But the reality is no, it's just this idea that there are forces that we can't see. We can't see gravity, everybody's comfortable with that. And in this case, we can't see magnetism, but the magnetic force is what's able to push that ball without touching it. So it's going to do that a couple times. And again, a lot of these experiments, they do it a couple times to really get people to observe it a few times and understand it before it ends.
So this carousel, it's going to be rotating, and each one of these is an active, live, individual project, different students, different focuses, using all the manufacturing that you have in your academy.
Exactly. And one of the hallmarks of our program is we really try to expose all students to manufacturing. Our program is diverse, so 50% of the students that worked on this project are young women. And so that's something that's unprecedented, I think, in the engineering and manufacturing communities, to see an educational institution which is actually exposing such a broad base of folks to manufacturing, and not only exposing to them in terms of seeing manufacturing, but actually the students doing the manufacturing.
So it's merged with the art department?
It's merged with, we have art, it's not that we're merged with the art department, we have an art teacher that works in our program, and so we're able to give art credit, engineering credit, science credit. And what we are also trying to do is we're trying to show how it's possible to blend all of the different subjects related to product development together in a way where every student can experience all of that. So if you look at a project like this and you think, well, what do the kids do? They're doing prototyping, they're doing testing, so they're doing test engineering, they're doing manufacturing, they're doing CAD, they're doing the science behind the experiments, they're doing the engineering work to make sure the project works, they're doing the aesthetic aspect of it, so the design from the aesthetic standpoint. They're doing market research in terms of, are people going to like it? They're testing out the projects and bringing people in and saying, hey, is this compelling? Are you enjoying the project? So just every step of what it would take in a company to develop a project, these kids are engaged in all the facets of that process. And that's really a profound experience, because when you do go to a company, it's unlikely that you're going to be able to do every part of the product development cycle. But through our kids having exposure to every part of the product development cycle, we believe that when they go off and work for a company that does make products, that they're going to be much more effective in that industry by being able to communicate with the folks from every different discipline and be able to be really the glue. And when you think about it, one of the hardest things to find are effective product managers who really, and project managers who understand all the different aspects of the project. And so I think we're giving students in our program this real kind of a introduction to project and product management by exposing them to all the different aspects of the product development cycle.
Yeah, I don't see much on here that it's all different. Every inch, every foot has got a different approach, right, different parts, different needs. So what else does this moves around the carousel?
So we'll move it on the next round. Let's go ahead and we'll look at a sector that I've shown you already so that we can see it. So this one right here was designed by 4 students. It was this first project right here. This project was created by a girl. Her name is Bella Dark, and you can see this is all automated and it's coming out right here. Her project, because it was this chaotic pendulum, didn't really fit, and as a result, we had to create it so that it would actually come out like this. So it was able to do this motion outside of the project. It's rare. Not all the ones have something that actually telescopes out. But again, Bella wanted to show chaos theory, and a chaotic pendulum is a way to demonstrate that. This next student was created by a student, his name was Jesse, and Jesse was really interested in this notion of creating this pendulum wave array. And so the whole idea was, well, how do we do this in an automated fashion? We'd seen it on a YouTube video, it was cool, but it was always people coming in and pushing and holding back all the balls. And so he was able to work with me, and we worked together to develop this method to get this pendulum wave array to work in this way.
So when these kids are working on these projects, when they get to the CNC, you have instructors that are familiar with our machines,
yes,
and taking them through those final steps and machining as much as you can.
Exactly. So a lot of the students will do a lot of work on the manual machines, but then when there are projects specifically like the one we're going to look at right here, this project was made by Tatiana. It's going to go in a minute, but we can start talking about it now. So for example, she had to make 169 of these little balls right here, and so every one of these holes was done on a CNC machine, and she was operating the CNC. It was a Haas lathe to do that. And all of these rods right here, they also have this feature on the end, and there's another feature on the other end, and that was also done on the Haas CNC lathe. So she was able to become familiar with that and really realize, look, if I'm going to make 169 parts times 2, it doesn't make sense for me to do that on the manual lathe. Let's do this setup right now and get this set up. And so she worked with our machine shop manager, Stefan, and he trained her how to use it, and she went through and made this. And so as a result, we now have this pendulum wave array. So in this case, the product up here was done on the Haas CNC, and some of this other stuff down here where there's a replicated many times was done on our laser cutter. And then there's some spacers down here, which I believe were also done on the CNC lathe.
You showed me something earlier, was the Infinity.
Yeah.
So let's just see that again.
We'll come and go back to that.
Oh.
So this is cool. This is an inverted pendulum right here. And so what this thing is able to do is this thing's actually computer controlled, and this gets into the whole notion of even teaching kids about control, which is again what a CNC is. This pendulum right here self-writes itself consistently and uses the same type of algorithms that you would use to move a CNC bed around. And so for us, when we look at that, it even gets to this other level of like when our students are going through a program like this, they're actually learning the types of things that you would need to go work ultimately at a company like Haas, and they're doing it in the high school. Getting this early exposure to something like control can really help a student decide whether or not that's something they want to move into as they get older. So I'll go ahead and I'll run the light table right now.
How many students are in your program at this point?
Yeah. There are 400 students in the program. 200 of the students are girls. Again, we talked about that. It's a really powerful thing that I'm really proud of, is that we've got young women. We also have diversity in terms of different people from different socioeconomic backgrounds, different backgrounds in terms of their heritage as well. And so that's one of the things that's really, again, that's compelling about our program from my perspective, is like we're really opening the tent. Like we're really saying engineering and manufacturing and all that, there's a vision that people have when they think of who does engineering and manufacturing. And I think one of the special things is that when folks come visit our program and they look around, it totally changes what they think. And it changes what they think in terms of like, look, like obviously these kids are all here and they're loving it. And when you have that paradigm shift and you go, oh my God, like this isn't the stereotype that I had in my head isn't something that is actually fundamentally true. That stereotype is actually fake. And that's really the thing that's great, is disrupting that whole thing. Disrupting this whole notion of who sees themselves as an engineer. So we'll go ahead and we'll run optics right now, and I'll continue to talk about this notion of disruption.
How long did it take you to create this carousel?
So this was a 9-month process. We actually created this entire thing, designed it, fabricated it, prototyped it, spec'd it out, ordered the parts. I mean, all the different steps in the process, we did it all in 1 school year. And that was really one of the things that was really interesting, is what could you do in 1 school year with the seniors in this capstone class? And so I was talking about this notion of disruption. I'm really interested in showing what is possible from a disruptive standpoint in education. Meaning, what is possible in a school setting? People, I think we aim too low. We have this notion of like, okay, the bar is here. I think the bar is beyond what we even can conceive of. And what I try to do each year as we create these projects is I'm just trying to push the bar higher and higher, set the bar higher and higher, so that we can actually move all of education in this direction. So rather than us just moving a little bit forward and go, hey, isn't this cool? It's a little bit different. I want to be so far out there that it causes change, that you get people to look and you go, whoa, they're way out there. They're not just like a little bit ahead of us, they're way the heck out there. We better take all of our stuff and we better take a big step forward, or we're just going to be left in the dust. And you know, people often talk about us competing with other countries and all that kind of stuff. This is the type of thing we want to be doing. Standardized tests, that's not what we want to be focusing on. We want to focus on what can we actually work on and create with our students. So this next one's fun, and it'll show up well on video. This is an optics table, and it's going to show the fundamental principles of basic optics using lasers, using 3 parallel lasers right here. And then we were able to actually create this fog so you could see the lasers. So if I blow the fog away, you actually can't see the lasers, but the fog quickly comes back. And that was one of the big challenges of this project, was how do we generate the fog in a safe way? So this is actually it's water vapor. It's just a cool water vapor using the same process that a nebulizer would use if you have bronchitis and you're breathing through one of those breathing masks. So it's non-toxic, you know, and it's great. It doesn't, you know, it's non-corrosive. These are all good things.
Now, when I walked in, it was turning, and every part was active and doing its own.
After we run this one, what I'll do, just so you can kind of close out the video, is I'll run the whole thing and turn it all on, and we call that insane mode. Kind of borrow that from Tesla. Tesla Motors has an insane mode where the car accelerates at the peak value before basically the wheels will slip traction. And they're able to do that because they're using an electric motor, is my understanding, because the torque on the electric motor gives you just peak acceleration when you're stopped. And so we kind of borrow that idea of insane mode, is when we run everything at once and we rotate the carousel simultaneously. You can actually see over here, we're about to move out. These are all the sector stands that we're going to be bringing in here. We're staging the whole process to start removing all of these sectors and move this to the next location. And one of the reasons we were able to make it modular is because the inside was developed on the Haas CNC, and through making on the Haas CNC, we were able to really replicate this kind of themed modularity, all not only for the parts on the inside, but the parts on the inside of the sector, but the parts on the inside of the actual carousel. And that really allowed us to be able to do that. So that's critical. If the kids were doing all that without the CNC, the lack of precision and the lack of repeatability wouldn't have allowed this thing to be as modular as it is. But the fact that we were able to build the whole thing on that allowed for that modularity. So this project is about to run.
Yeah, they're about to shut it down and take it apart. Okay.
We're going to run 3 more minutes, Gary, and then we're done.
That's fine. We're going to go back and make another trip with sector.
Okay, perfect. Lyle's supposed to come here and talk to me anyway.
Yeah, he's on his way.
Do you turn off the lights too when you do this sometimes?
No, because a lot of stuff isn't visible in the lights. Some of it would obviously play well in the lights, but some of it's not going to do very well in the lights. Okay, so we're going to do the run all. So you're going to want to focus right now on the top of the carousel, because that's where all the balls come out, just to kind of highlight this notion of everything coming out. So you're going to want to probably walk over here. Some of the stuff is shut down supervised Disneyland where we're doing some refurbishment on it. So we've had this here for over 2 months, and even in this proof of concept, and this is really a prototype, to have a prototype be able to last for 2 months and be working, consistently and be able to work so well has been very encouraging for us in this whole notion of can we build these exhibits that will last on into the future.
Is there more project like this in the funnel?
In the funnel,
you got a future roadmap?
What we're doing right now is the project we're working on this year. We've been showing this to students, and students love it.
And parents too, right?
Parents too. But the one comment that we get, you're going to want to look at that one. I don't know how well it'll show up on video, but it's going to be awesome for you to watch. Is the one comment we get from kids and parents is, oh, it'd be so cool if we could touch it and interact with it. And so what we're making this video is called Physics Arcade. And again, the entire guts of it,
Physics Arcade.
the entire guts of it are all going to be made on the Haas CNCs. Because we're going to have these repeated, consoles that we make game consoles, and what's going to happen is kids are actually be able to, just like you're here, you're able to watch it. They'll be able to interact with it via a user interface and actually change what they see happening. So, like remember we saw the one with the optics laser table. Imagine kids being able to turn the lasers on and off, move the lenses where they wanted them, and do all of that kind of play. They're going to be able to do all that to help them learn.
In your experience, have you seen any other school as institution?
I haven't seen.
Yeah.
I haven't even seen any company try to produce anything that's a kinetic installation that's as diverse as this. Typically, when folks do a kinetic installation, if they're of this magnitude, they'll have a repeated theme throughout, and so you just have a lot of the same thing. In this case, we were creating this large installation where every project is different. I mean, look over here, you got a ball being blown up and down by a ping pong ball. Over here, you've got these little air cars moving. Here, you've got sand vibrating at different, frequencies. In here. I mean, there's all kinds of different stuff. It's all different everywhere you look.
And so the kids that are coming in the program, are you seeing them sort of get lit up, getting excited?
I think so.
Possibilities?
I think one of the things that people are finding exciting, it's kind of a hard concept for them to get at the beginning. But, Jonathan over here worked on the project.
Hey.
And the concepts that people are getting now is that, wow, we're creating real things that are going out into the real world. And that's this thing that kids haven't had a lot of exposure to it yet, but I anticipate as we move forward with each of these projects that really connect with the world, that the kids are going to really go, they're going to start saying, the thing I love about the Pueblos Engineering Academy, in addition to all this exposure to all this different types of stuff, is that the things I make go out and interact with the world. They go out and people outside of school are impacted and affected by them. It's so profound. I mean, I'm here, I've been doing this for 2 months now, and we just had a class of kids come in here, and to watch them run around in just a state of just joy, looking and going, show me this one, I want to see that one, and they're so excited. I mean, that's really it. I mean, think about it. We're getting these young kids excited about making, creating, and about science. So that's what's where we are right now. But again, this year and into the future, our whole plan is to do this type of thing each and every year.
All right, well, have any final thoughts?
I think that really what I would like to say is we're really interested in full kind of service education across product development, and we've been really excited to be able to have our students have access to machinery, especially for rapid fabrication like Haas products, so that we can make this possible. And I can say unequivocally that without Haas being in our facility, without us having access to Haas machinery, we would not have been able to create this project. There are parts of this that just simply could not be done in the time or with the level of precision without the Haas. And the thing that I like is that we use the automated machinery in a way where we still are teaching kids the fundamentals of machine shop. So we don't say, oh, well, we have automation, let's do everything using automation. We look at projects and we say, this project, we're going to make one of these. Let's do this on the manual machine and let the kids start to really understand how fabrication looks. But when it comes to the time where we're going to make 20 of something complicated, well, that's the point where we start to say, let's start to engage the Haas system and really bring the kids into that realm. So, I mean, kind of in a nutshell, it's really the excitement that I have is just full service product development across the board and having access to every tool imaginable that you would need to fabricate. And in our case, we look to Haas as one of the tools we draw from, in addition to the many other tools we have in our shop.
All right, well, Amir, I appreciate it. Thank you for just letting me do a video here real quickly.
Yeah,
I
absolutely.
appreciate the exposure and
And thanks for coming in and taking the time to check it out. I appreciate it.